Good morning, students. So in today's class we are going to learn about long answer questions from electrochemistry chapter. Okay, so let us go for 5 long answer questions which are there. Okay, we are going to cover them in this video. So first question chudandi, what are electrochemical cells? How are they constructed? Explain the working of galvanic cell. Write any 3 differences between electrochemical cell and electrolytic cell. So first of all, electrochemical cell అంటే ఏంటంటే it is the device which converts chemical energy into electrical energy, or which can use electrical energy to perform chemical reactions. Okay, so this is about electrochemical cell. Generally, electrochemical cell, the type of reactions involved in electrochemical cell are what? Redox reactions. Okay, now so spontaneous redox reactions will happen in case of electrochemical cells, and generally they consist of what? They consist of 2 electrodes, anode and cathode, immersed in different electrolytes. Okay, now if it is electrochemical cell, you will have 2 different electrolytes, but if it is electrolytic cell, both the electrodes are immersed in one electrolyte only. Okay, so primarily we have 2 types of cells. First one is galvanic cell and the second one is electrolytic cell. Okay, so now we have to learn about them. So construction of a galvanic cell. Galvanic cell, like for example Daniel cell, consists of what? 2 separate half cells. మీకు తెలుసు కదా, 2 separate half cells ఉంటాయి. Anode, which is called as oxidation half cell. In that what will be there? A zinc rod or zinc metal rod submerged in aqueous zinc sulfate solution. Okay, it is negative electrode. Anode is what? Negative electrode. You have to remember it like LOAN, LOAN. Left oxidation, anode negative. సో ఇది గుర్తుపెట్టుకుంటే ఏది దేనిగా యూజ్ చేస్తారు అన్నది మీకు గుర్తుంటుంది అనమాట. ఓకే, ఇట్స్ అ నెగిటివ్ ఎలక్ట్రోడ్. అండ్ నెక్స్ట్ క్యాథోడ్, it's a reduction half cell, a copper metal rod submerged in aqueous copper sulfate solution. It is positive electrode. Okay, then salt bridge. Salt bridge is a U-shaped tube filled with an electrolytic gel like KCl in agar-agar solution that connects both the half cells. రెండు half cells ని కనెక్ట్ చేయడానికి ఒక ఇన్వర్టెడ్ U-shaped tube అనేది పెడతారనమాట. That you call it as salt bridge. It acts as a bridge between both the ఆక్సిడేషన్ అండ్ రిడక్షన్ హాఫ్ సెల్స్. ఆ రెండింటిని కనెక్ట్ చేస్తుంది అనమాట. ఓకే, సో వై ఇట్ ఈస్ బీయింగ్ కనెక్టెడ్? టు మెయింటైన్ ద ఎలక్ట్రికల్ న్యూట్రాలిటీ అండ్ టు అవాయిడ్ చార్జ్ అక్యూమిలేషన్. సో ఆఫ్టర్ సమ్ టైమ్ వెన్ యూ స్టార్ట్ ఎలక్ట్రిసిటీ టు పాస్ త్రూ ఇట్, వాట్ హ్యాపన్స్ ఈస్ ఆల్ ద positively charged Zn2 plus ions gets accumulated in this half cell, and Cu2 plus ions gets accumulated in cathode half cell. Okay, so that charge accumulation has to be stopped. So in order to maintain the continuous flow of electrons or flow of ions, this salt bridge is connected. Okay, so that is the role of the salt bridge, to maintain what? Electrical neutrality and to complete the circuit. Okay, and to avoid charge accumulation. These 3 points you can remember for role of salt bridge. And then external circuit, a conducting wire connecting the zinc and copper electrodes, usually connected by voltmeter. It acts as what? External circuit. So working of a galvanic cell చూద్దాం. At anode, oxidation takes place. Oxidation means what? Loss of electrons. So zinc loses 2 electrons and forms Zn plus 2 ions. At cathode, reduction takes place. So the copper takes electrons and gets deposited on cathode as copper deposit. Okay, then salt bridge. As zinc ions, Zn plus 2 ions build up at anode and sulfate ions build up at cathode, they get accumulated. So now because of that accumulation, electrical continuous flow of electrons cannot take place. So to maintain continuity of flow of electrons, salt bridge plays an important role. It releases K plus and Cl minus ions to neutralize the charges and ensures the continuous flow of electrons. Okay, now so that charge accumulation can be prevented. Okay, so that is the main importance of salt bridge. Now he is asking us to write the differences, 3 differences between galvanic cell and electrolytic cell. సో ఎనర్జీ కన్వర్షన్లో ఫస్ట్ పాయింట్ వస్తే galvanic cell converts chemical energy to electrical energy, whereas electrolytic cell converts electrical energy to chemical energy. Then spontaneity of the reaction, second point koste, second feature is about spontaneity of the reaction. So adochesi galvanic cells are driven by spontaneous redox reactions, whereas electrolytic cells are driven by non-spontaneous redox reactions using external battery. And then electrode sign, galvanic cell లో యానోడ్ నెగిటివ్ ఉంటుంది, క్యాథోడ్ పాజిటివ్ ఉంటుంది, whereas in electrolytic cell యానోడ్ is positive, cathode is negative. So these are the differences between galvanic cell and electrolytic cell. Okay, so first question is completed. So please note down. So question number 2 చూద్దాం. Give the different types of batteries and explain the construction and working of each type of battery. This is your second question. So what is meant by battery? Battery is a device which converts stored chemical into electrical energy through electrochemical reactions. Already stored chemical will be there inside the battery, which is used for converting into electrical energy. So that device you call it as a battery. So batteries are classified into two main categories. First one is primary and second one is secondary. So primary batteries are considered as non-rechargeable batteries, and secondary batteries are considered as rechargeable batteries. So primary batteries, if you go with, these batteries undergo irreversible chemical reactions. Okay na, primary batteries will undergo irreversible chemical reactions and cannot be recharged once the stored chemical gets depleted. Okay na, once the chemical which is stored inside it, if it gets depleted, you cannot recharge it. Okay, so for example, Leclanche cell or dry cell. So in this, what is cathode, what is anode, that all we have to write. So Leclanche cell or dry cell. So in this, anode is what? It's a negative terminal and cylindrical zinc casing. Okay na, a cylindrical zinc rod or cylindrical zinc container. Cylindrical zinc container that holds all the internal components of a cell. It is considered as anode. Okay. So here cathode is positive and it is a centrally located carbon or graphite rod capped with a brass tip. So here cathode is what? Cathode is a positive terminal. Which one will act as cathode here? Centrally located carbon or graphite rod capped with a brass tip is used as cathode. And then electrolyte. Electrolyte is the moist paste of ammonium chloride and zinc chloride that allows ions to flow. Okay, so this paste acts as electrolyte. And here we are going to use one depolarizer. Okay, now, so a black paste of manganese dioxide or carbon powder is packed around the carbon rod. This prevents the production of hydrogen gas. That's why it is called as what? Depolarizer. It prevents the production of hydrogen gas, which may otherwise insulate the electrode. Okay, now, see, hydrogen gas may be released. So if that hydrogen gas is released, it may insulate the electrode so that electron flow can be stopped. So to depolarize that, a black paste of manganese dioxide is surrounded around the brass tip, around the graphite rod. Okay, so this is called as depolarizer. Next, coming to working principle. When the cell is connected to the electrical device, it generates steady direct current of 1.5 volts through spontaneous redox reactions. Okay, now through spontaneous redox reactions, it produces a steady current of 1.5 volts of energy. Electrical energy can be produced from that. So now we are going to learn about the cell reactions. At anode, you all know that oxidation takes place at anode, and the anode reaction is what? Zinc gives rise to Zn plus 2 electrons. And at cathode, reduction takes place, and at cathode, the ammonium ions and manganese dioxide, they gain electrons and forms Mn2O3 plus 2NH3 plus 2H2O. These two are the cathode and anode reactions. So overall reaction వచ్చేసి Zn plus 2MnO2 plus 2NH4 plus gives rise to Zn plus 2 plus Mn2O3 plus 2NH3 plus H2O. So this is overall reaction which happens inside the cell. Okay, now let us move on to the secondary cells. Secondary cells are what? They are rechargeable batteries. Means they utilize reversible chemical reactions. When power is depleted, applying the electric current in the reverse direction. Means you will be keeping charging. Okay, so if you are keeping charging, what will happen? The current is applied in the reverse direction and it forces the chemical reaction in the backward direction, restoring its original reaction and storing the energy for reuse. Okay now, so reversible chemical reaction takes place by applying charging to that particular battery or a cell. The reversible chemical reaction restores energy again. Okay, so this is this kind of cells, you call them as what? Secondary cells. Okay, example is lead storage battery, which is commonly used in cars. So in that lead storage battery, anode is a grid of lead packed with spongy lead. You will take it as anode, and cathode is also a grid of lead packed with lead oxide. Here a grid of lead packed with spongy lead. You will take spongy lead as anode, and cathode is what? Is also a grid of lead packed with lead oxide, PbO2. Okay, so these two acts as cathode and anode. Now coming to electrolyte. Electrolyte is a dilute solution of H2SO4 which is 38% by weight. Weight percentage 38%. Such kind of solution you are going to use it as an electrolyte. Okay, so this is about cathode, anode and electrolyte for secondary cells. So next we are going to learn about the working. Working means discharge, how the battery is going to work, means how it provides power. You call that as discharging or providing power. So the lead anode and the lead dioxide cathode react with H2SO4 producing lead sulfate. Okay, now lead reacts with H2SO4 and produces lead sulfate at both the electrodes and releasing water into the electrolyte. This process generates an electric current. It releases water into the electrolyte. So this process generates electric current. Okay, next coming to charging. So again once the power is provided, we keep using the battery. So once the battery gets discharged, okay, now completed. So charging, if it completed, again we need to plug in to give charging to it. So charging, how it happens? Passing an external electric current through the cell reverses this reaction. Okay, now if you are passing external current through the cell, it reverses the chemical reaction. Okay, it reverses the chemical reaction. The lead sulfate PbSO4 on the plate is converted back to lead and lead dioxide. We have taken spongy lead as anode and lead dioxide as cathode. So when you are applying charging, the lead sulfate which is so formed converts back to spongy lead and lead dioxide. Means cathode and anode are again restored. Okay, and the concentration of H2SO4 is also restored. In that way, if you keep charging, the reaction becomes reversible, and whatever the depleted substance, means charging, if it gets completed, again you can recharge it and you can reuse it. That is the special advantage of secondary cells. Okay, so this is about secondary cells. Note down. So question number 3, చూడండి ఇది ఒక న్యూమరికల్. Calculate the concentration of silver ions in the cell constructed by using 0.1 m concentration of Cu2 plus and Ag plus ions. Cu and Ag metals are used as electrodes. The cell potential is given as 0.422 volts. Okay, so this is a question which is given. So in this question, what is given to you, what you are asked to find. If you read the question 2 times, you will be understanding how to proceed to calculate what is being asked in the question. Okay, he is asking us to calculate the concentration of silver ions. Means concentration of Ag plus ions he is asking us to calculate. What is given? 0.1 m concentration of Cu2 plus ions and Ag plus ions. See here, concentration of Cu2 plus ions is given as 0.1 m. He is asking us to find the concentration of Ag plus ions. Here Cu and Ag metals are used as electrodes and cell potential is given as 0.422 volts. Okay, so this is given, and this is also given, like E naught of Ag plus Ag is given as 0.80 volts and E naught of Cu2 plus and Cu is given as 0.34 volts. Okay, this is also given in the question. Then he is asking us to find what? Concentration of silver, Ag plus ions concentration we should find. So if these two are given, we can identify E naught of cell. E naught of cell, what is the formula? E cathode minus E anode. Okay, whatever value is bigger, given bigger value, that you can take it as cathode. Okay, here 0.80 volts is a bigger value. You can take it as E of cathode minus 0.34, which will get 0.46 volts. So E naught of cell, we get it as 0.46 volts. Okay, next, once if you check with the overall reaction, overall cell reaction is Cu plus 2Ag plus gives rise to Cu2 plus 2Ag. This is your overall reaction. From this overall reaction, you can identify what are how many electrons are transferred, the number of electrons transferred. If you observe this reaction, Cu gives rise to Cu2 plus. Number of electrons transferred, how many? 2 are there. So N value is 2. Now you can apply Nernst equation. What is Nernst equation? E of a cell is equals to E naught of cell minus 0.0591 by N log Q. Okay, so E cell, he gave it as 0.422 volts. This is given in the question. Okay, E naught of cell, we got it here 0.46 volts. And N value, we got it as 2. And log Q means what? Q means concentration of products by concentration of reactants. Here what are products and what are reactants? If you observe carefully the overall reaction, okay, here Cu and Ag are solids. This is solid and this is also solid. So generally we will not consider solid substances, or concentration of solids has to be taken as unity. Okay, then Q can be written as what? Concentration of products by concentration of reactants. Concentration of products is Cu2 plus. Here in product side Cu2 plus. These two are aqueous, so we consider them only. Okay now. So Cu2 plus is there in the product side and Ag plus is there in the reactant side. But for Ag plus, coefficient is given as 2. Okay, so it should be raised to its power. So Ag plus whole square should be there. Now our aim is to find the concentration of Ag plus whole square only. In the question they also gave Cu2 plus ions concentration is also given as 0.1 m. Okay, so everything is known to us. In this formula, E cell is given as 0.422, E naught cell we got it as 0.46, and N value we got it as 2, and Q value is in that Cu2 plus by Ag plus ions whole square. Cu2 plus is also given as 0.1. So what is our aim? Our aim is to find only Ag plus ions whole square. Okay now. So let us rub this side and we'll do. So I am substituting all the known values which are there, which are known to us in the Nernst equation. So what values are known to us? E of a cell is given as 0.422 is equal to E naught of cell, we got it as 0.46 minus 0.0591 by N value is 2, and log Q value can be written as, for Cu2 plus they gave it as 0.1 m molarity by this Ag plus whole square, as it is we will write. Ag plus whole square as it is we will write. Okay, so this we have to simplify it now, and we have to find what? Ag plus whole square. Okay, so this value calculation we are going to check it now. So that is equals to 0.422 is equals to 0.46 minus 0.0295 log 0.1 by Ag plus whole square. Okay, so this value I am bringing this side. So 0.422 minus 0.46 or 0.42 minus 0.46 directly will take is equal to minus 0.0295 log 0.1 by Ag plus whole square. Okay, so 0.42 minus 0.46 can be taken as 0 minus 0.04 is equal to minus 0.0295 log 0.1 by Ag plus whole square. Okay, so here minus minus gets cancelled. Okay, so 0.04 is equals to 0.0295 log 0.1 by Ag plus whole square. Okay, so now log 0.1 by Ag plus whole square is equal to 0.04 by 0.0295. So if you calculate this, what is the value which you are going to get? I think it is 1.286. Okay, 0.04 by 0.0295 is 1.286. So log of 0.1 by Ag plus whole square is this 1.286. Now we have to find this Ag plus whole square. Okay, so let me rub that side and we'll do that. So log of 0.1 by Ag plus whole square is equal to 1.286 we got. So therefore 0.1 by Ag plus whole square is equal to anti-log of 1.286. Okay, so anti-log of 1.286. So that anti-log of 1.286 we get it as 19.32. Okay, check it in the logarithmic table. You have to check this. So if you want Ag plus whole square, you have to bring this 19.32 to the denominator. 0.1 by 19.32. So 0.1 by 19.32 is 0.005176. 0.005176. So this is Ag plus whole square. Okay, now 0.005176 is Ag plus whole square. We want Ag plus only. So it will be square root of 0.005176, which is equal to approximately 0.072. Okay, now 0.072. Okay, so this is your answer. He is asking us to calculate concentration of Ag plus ions. So here this anti-log values and all we can't remember. Either they may provide anti-log values in the bracket, then you can directly substitute and you can check over. Okay, so this is your question number 3. Please note down. Next question number 4 చూద్దాం. Calculate the degree of dissociation alpha of CH3COOH at 298 Kelvin. Given that lambda m of CH3COOH is 11.75 and lambda infinity m, this is lambda m means molar conductivity and lambda infinity means limiting molar conductivity. Okay, now for individual ions he has given. Okay, now CH3COOH actually dissociates into what? CH3COO minus plus H plus. So for this molar conductivity is given as 11.75 and for each ion limiting molar conductivity is given as for acetate ion it is given as 40.95 and for H plus ion it is given as 349.15 centimeter square mole inverse. Now he is asking us to calculate what? Degree of dissociation alpha. To find the degree of dissociation, this is the formula. Alpha is equals to molar conductivity by limiting molar conductivity of the same substance. Okay, so using Kohlrausch laws, we can write lambda infinity m of CH3COOH. First ఇది ఫైండ్ చేయాలి. డినామినేటర్ ఏముంది ఇక్కడ? లాంబ్డా ఇన్ఫినిటీ m ఉంది. లాంబ్డా ఇన్ఫినిటీ m క్యాలిక్యులేట్ చేయాలంటే Kohlrausch laws యూజ్ చేయాలి. ఓకే, సో దట్ ఈస్ ఈక్వల్స్ టు వాట్? లాంబ్డా ఇన్ఫినిటీ ఆఫ్ acetate ion plus lambda infinity of H plus ion. Okay, now limiting molar conductivity of weak electrolyte can be taken as sum of the molar conductivities of each individual component. That is only called as what? Kohlrausch law. So Kohlrausch law prakaranga lambda infinity of CH3COOH calculate cheyalante we need to add the individual values of cation and anion respectively. So cation ki 40.95 ఇచ్చారు, anion కి వచ్చేసి 349.15 ఇచ్చారు. సో రెండు యాడ్ చేస్తే మీకు ఎంత వస్తుంది? 390.165 వస్తుంది. దట్ ఈస్ లిమిటింగ్ మోలార్ కండక్టివిటీ ఆఫ్ ఎలక్ట్రోలైట్, వీక్ ఎలక్ట్రోలైట్ ఎసిటిక్ యాసిడ్. సో ఆల్ఫా ఫార్ములా వచ్చేసి లాంబ్డా ఎం బై లాంబ్డా ఇన్ఫినిటీ ఎం. లాంబ్డా ఎం క్వశ్చన్లో వాళ్ళే ఇచ్చారు 11.75 అని. సో 11.75 by we got lambda infinity m, how much we got? 390.165. So this division if you go with, that is equals to how much? Alpha value ఎంత వచ్చింది మనకి? 0.03115. అంటే అప్రాక్సిమేట్ కరెక్టింగ్ టు 2 digits వరకు తీసుకుంటే 0.03, which is alpha is equals to 3 into 10 to the power of minus 2. Okay now, so that is only your alpha value answer. Okay, this is your fourth question, please note down. సో క్వశ్చన్ నెంబర్ 5 చూడండి. ఇందులో 2 questions ఉన్నాయి. ఫస్ట్ వన్ వచ్చేసి స్టేట్ అండ్ ఎక్స్ప్లెయిన్ కోల్రాష్ లా ఆఫ్ ఇండిపెండెంట్ మైగ్రేషన్ ఆఫ్ అయాన్స్ అలాంగ్ విత్ 2 అప్లికేషన్స్. అండ్ సెకండ్ క్వశ్చన్ వచ్చేసి డిఫైన్ మోలార్ కండక్టివిటీ అండ్ లిమిటింగ్ మోలార్ కండక్టివిటీ. సో ఫస్ట్ వన్ చూద్దాం, కోల్రాష్ లాస్. So Kohlrausch law statement is what? At infinite dilution, the molar conductivity of an electrolyte is the sum of the individual components, sum of the contributions of each constituent, that is cation and anion. Okay, you have to add, like you can mathematically express this like this, lambda infinity m, that means limiting molar conductivity at infinite dilution. It is given by lambda of cation plus lambda of anion. Like suppose for example, if you take acetic acid, it is CH3COOH. It generally splits into its ion CH3COO minus plus H plus. So cation H plus lambda of anion, acetate ion. Like that only you can take other 2 examples. Suppose if you have 2 cations or 3 cations, 3 anions like that, then you have to multiply the number with that particular number of cation or anion also. Like for example, in Ca3PO4 taken twice is there. So if it splits into its ions, you will get 3 Ca2 plus and 2 PO4 3 minus ions. Okay now, so that's why 3 into lambda Ca2 plus 2 into lambda PO4 minus 3. So like that it will split and then it has to be added. That means number of cations and number of anions also to be multiplied, and then you have to add that particular sum. Okay, so that is the mathematical expression for what? Kohlrausch law. Now what are the applications of Kohlrausch laws? There are 2 applications are there. First one is to calculate limiting molar conductivity of weak electrolytes. This is only the application. To calculate limiting molar conductivity of weak electrolytes. That is point number 1. I mean first application. And second application vachesi to calculate degree of dissociation, alpha. How to calculate degree of dissociation? In fourth question only we have seen lambda m by lambda infinity m. To calculate alpha, we have the formula what? Lambda m by lambda infinity m. So to calculate degree of dissociation also, Kohlrausch laws are applicable. Now second part, next దాంట్లో చూద్దాం. I mean బోర్డ్ డ్రాప్ చేసి రాసుకుందాం. సో నెక్స్ట్ లాస్ట్ బీ బిట్ చూడండి, మోలార్ కండక్టివిటీ. సో lambda m definition is what? Lambda m is a conducting power of all the ions produced by dissolving 1 mole of electrolyte of a solution. Okay na, conductivity of all the ions produced by dissolving 1 mole of an electrolyte in the solution. So lambda m is equals to k into 1000 by m. M means molarity. Here lambda m means molar conductivity and k is what? Conductivity, not molar conductivity. K is conductivity into 1000 by m. M means what? Molarity. So formula for molar conductivity is k into 1000 by m. Okay, so this is the formula. Now coming to limiting molar conductivity, means molar conductivity at infinite dilution. You call it as what? Limiting molar conductivity. You will represent that with lambda infinity m. So it is the maximum value of molar conductivity reached when the concentration of the electrolyte in the solution almost approaches to 0. Almost the concentration totally becomes 0. Then that you call it as what? limiting molar conductivity. So in such case, when the concentration is totally becoming zero, what will happen? All the ions are very independently they can move. That's why Kohlrausch law is called as Kohlrausch law of independent migration of ions. Okay now, so at infinite dilution, migration of ions will be very free, independently they move. Okay, so that is called as limiting molar conductivity. So up to here, your all long answer questions have been completed. So please keep practicing, write and practice, make a note of every question in your notebook and then practice. కంపల్సరీగా మీకు ఇందులోంచి ఒక న్యూమరికల్ అయితే ఎక్స్పెక్ట్ చేస్తున్నాం. 8 మార్క్స్ న్యూమరికల్ అంటే ఇట్స్ వెరీ ఇంపార్టెంట్ అనమాట. ఈజీగా చేయొచ్చు కూడా. ఫార్ములా తెలిస్తే డైరెక్ట్గా సబ్స్టిట్యూట్ చేసేసుకుని సమ్ చేసేసుకోవచ్చు. సో దట్స్ వై ఫోకస్ మోర్ ఆన్ numericals in this area, then you will be getting full marks. Okay, thank you very much children. Thank you for watching. Bye.